Howdy, Huskies. Welcome to another edition of Trig with not virtual Trig, that is. Hi, guys. Hope you're doing well. We are going to go ahead and jump into 5.2a today. And we're going to go ahead and take a look at our sum and difference theorems. But we're going to look at it when we don't necessarily have the angle measurements. And we're going to be living in the world of X's and Y's today. So we're going to go ahead and use that. But before, let's go ahead and have you guys try your review questions and then hit the play button and see if you're right. Alrighty, welcome back. So on our first one, we got to remember what the graph of cotangent looks like. And so I have that over here. Obviously, you can see that. And then remember, our asymptote are going to be at 0 and pi. So remember, it's going to be, because it's domain, that's our side to side, so it's all real numbers except where there's an asymptote. So you can basically have it three different ways depending on what your teacher is looking for. Our first asymptote's at 0, so you could write it that way. Or you could say the first positive 0, which is at pi, you can write it that way. And then remember, you have to have the pi k because that's the period, plus k is how many times we're going to continue on forward. Alrighty, frequency of this graph is we gotta steal our b and plug it into our period formula to find what the period is. And then remember, frequency, which we see down here, is 1 over the period. So you just take the period and flip it and you're good to go. And then this last one should be an easy one. This one is going to be one of our Pythagorean identities. So that's just rewriting it. So it's tangent squared x. Alrighty. So if we recall what we saw yesterday, we were using a lot of, that's our provings. We're doing a lot of algebra with just actually having these values, and we were looking for those sum and difference theorems. Well, today, as I mentioned earlier, we're going to be looking at stuff when it's an x and a y, okay? And what we're going to give us is they're going to give us a sine or a cosine or something like that, as well as a location, because we need to know where to draw it. And then we're going to find three things. So even though we only have 3 examples, there's going to be 3 parts of it. So let's make sure we're cool with our formulas first. So let's go ahead and make sure we're good. So when we're sine, it's going to be the sine of x, and then the cosine of y. And then remember, this one, they match, so it's plus. And then the cosine of x and the sine of y. So that's going to be for our sine. Make sure we have that. For our cosine, it's going to be cosine x, cosine y, and then it's opposite of the sine, so this is going to be minus, and then sine of x and sine of y. And then last but not least is our tangent. Our tangent's the one that's a little bit saucy, so we have tangent x plus tangent y all over 1 minus tan x tan y. So we're going to be using these 3 formulas for each example, but our scenarios are going to be a little bit different. So what we're going to do is we're going to look at scenario 1 with our x and scenario 2 with our y, find all of our values, and then go to town. So because we're looking for sine, cosine, and tangent, we really need to find all the trig ratios. So let's start with sine. So it tells me that sine is in quadrant 1. So if I go ahead and do that off to the side here, it's going to be in our first quadrant, and I'm just going to go ahead and draw my triangle, put my x right here, and then remember, sine is opposite over hypo. So my opposite is 12, hypo is going to be 13, and then you're going to do Pythagorean theorem. Let's go ahead and just call this w. We're only going to do this for the first example, and then we'll give you the values going here on out to make this video go a little bit faster. So w squared plus 12 squared is equal to 13 squared. So this is going to be w squared plus 144 is equal to 169. W squared is equal to 25, so w is going to be 5. So now that we know what that is, boom shakalaka. And then this is obviously opposite, adjacent, and then hypo. And then we're going to use, obviously, our SOHCAHTOA to go ahead and set up all of our relationships. So this is all for, obviously, x. So we need to do the same thing for y. So we'll do another one really quickly. Make this go a little bit faster since we know, again, it's in quadrant 1. It says so right there. So I'm going to draw it as cosine is going to be adjacent over hypo. That was the worst hypo ever, but I think you'll forgive me. I like to put a y right there. This is going to be 3. This is going to be 5. It's a Pythagorean triple, so that's a 4. Okay, or do the Pythagorean theorem and you're good to go. So we'll call A, which is our rule of sine. So we'll do A. So I'm going to do sine of x, which in this case, if we go to our diagram, is going to be opposite over hypo, so that's 12 over 13. And then cosine of y. So we go over here to y, and cosine is going to be 3 over 5. And then if we look at our rule, notice we have a plus right here. So I'm going to go plus, and then we have cosine x. So back over here to x, and our cosine is going to be 5 over 13. And then we'll do our sine of y, which is going to be 4 over 5. Alrighty, so it looks all good. So now we're just going to go ahead and multiply across here. So that's going to give me 12 over 65. And then I can't reduce this, so let's keep on rolling here. So that's going to be 20 over, I can't multiply. 12 times 3 is going to be 36. There we go. I checked my work beforehand, and I was like, that's not what I got. And so that's going to be 56 over 65, and that is our answer. So that's part A. Now let's cruise on over to part B. So part T is cosine, so we're going to use, obviously, our cosine rule. So cosine x, x, and then cosine y. So let's go over here. So cosine is going to be 5 over 13. And then for our next one, it's going to be 3, because again, adjacent over hypo, 3 over 13. It's 3 over 5. Got to get my fractions all right today. And so this is going to be, obviously, going to be 15 over that 65 again, which is pretty common considering we're using the same triangles. And then we have minus sine x, sine y. So going back again over to these triangles, x is going to be 12 over 13 and 4 over 5. So minus 12 over 13 and 4 over 5. And that's going to go ahead and become minus 48 over 65, which is a negative 33 over 65. Totally okay for our answers to be negative here. Alrighty, and then part C is going to be obviously with our tangents. So I'm going to use the same rules that we talked about yesterday or in the previous video. And since this is a fraction, you want to just do the numerator first and then worry about your denominator. So I'm going to look at just this tan x and tan y first, and then I'm going to go ahead and worry about my denominator. So the tangent of x is going to be 12 over 5, and the tangent of y is 4 over 3. Now again, we did that because we went over here, and we use our TOA of opposite over adjacent, opposite over adjacent. So that's going to be 12 over 5, 12 over 5, 12 over 5, and then 4 over 3. We don't have a common denominator here, so we're going to need to do that. That common denominator would be 15, so 3 and 3, 5 and 5. So this is going to be 36 over 15 plus 20 over 15, which is going to be 56 over 15. So again, this is our top part of our denominator. So now we're going to go ahead and worry about our denominator in the original function down here. So it's obviously going to be 1 minus tangent of x, which is going to be 12 over 5, and then 4 over 3 for tangent of y. Now, for easiness sake, we can do our cross canceling because 3 goes into 12 4 times, or you could just multiply across and reduce. So really, this is going to become 1 minus 16 over 5. So then we'll do our common denominator, put this over 1, 5, and 5. And so that's going to be 5 over 5 minus 16 over 5, which is going to be a negative 11 over 5. So again, this is our bottom fraction. So let's rewrite this fraction as it stands. So we have 56 over 15 divided by negative 11 over 5. And as we remembered from the previous video, this just means divide. So we're just going to flip this second fraction. So this becomes 56 over 15 times 5 over negative 11. So we're going to do the same canceling trick because 5 goes into 15 3 times. So this is going to be 56 over a negative 33. And that's going to be our answer. Again, you can put the negative wherever you want to. You can put on the bottom, on the top. Generally, it goes on the front or the top if you're going to write it. But that is C. So, ladies and gentlemen, boys and girls, this is the nuts and bolts of what we're going to be doing as we zoom out here. It is a little bit of work here, but we are just using our 3 main rules. So what's going to change in example 2 and example 3 is just the information that they're giving us. And so let's go ahead and jump in to example 2. So in example 2, again, they're giving us a sine of x, which is wonderful. And they're giving us a secant, so that's a little bit different there, of y. And I noticed that sine of x is in quadrant 3. So that's going to tell us something about the signs of everything. And then y is in quadrant 4. So let's go ahead and draw those out real quick. So erase all this just so it's not so cluttered here. So this is for x. So we know it's in quadrant 3, so it's down here. And so it's going to be negative 4 over 5 because it's opposite over hypo. So that means this would have to be 3 to make this work. Now it's going in the negative direction, so I'm going to make that a negative 3. Okay, so this is obviously for my x, so I'll put my x right there. And then we'll do our y. Our y is going to be in quadrant 4, so we're going to put it down here. Now it says secant, so secant is going to be obviously related to our cosine, and this is going to be hypo over adjacent. So my hypo is 13, my adjacent is 5, and that means that this is going to be a negative 12. We can do that by using Pythagorean theorem, and this is also going down. Okay. Now, one note on these two specifically. Because the formula is a squared plus b squared is equal to c squared for Pythagorean theorem, all these answers, if you were to solve, are going to come out as positive numbers. You need to know that this is the negative x direction here, the negative y direction here, and then the negative y direction here. But this right here is 5 is positive. And just as a heads up, your hypotenuse here, I'll do the hypotenuse here in both yellows, that should always be positive. So now that we have it all set to go, it's time to plug into our formulas. Okay, so again, we're going to go up to use these same 3 formulas again. So this is our first one for A. We'll make this an A, a B, and a C. Alrighty. So we'll go ahead and so we have sine of x. So that's negative 4/5. And then we have cosine of y, which is 5 over 13. And then we're going to go plus cosine of x, which is negative 3 over 5. And then the sine of y, which is negative 12 over 13. So now we're just off to the races. So this one's negative 20 over 65. And this is going to be a positive 36 over 65. And so this will be 16 over 65. So when you don't have to write out the rules and you can just look at these quick, then this doesn't become bad at all. All right, let's look at B. So for B, again, we're going to be using this rule right up here. So cosine x is going to be negative 3/5. And then cosine y is going to be 5 over 13. And then minus, then the sine of x, which is going to be negative 4/5. And then the sine of y, which is going to be negative 12/13. So let's multiply across. I'm going to get negative 15/65. And we have a lot of negatives over here, so you got to just making sure all your negatives are accounted for. So those two negatives are going to make a negative, or a positive, excuse me. But then that third one's going to make this negative, so minus 48/65. And since both of those are negative, it's going to be negative 63/65. And that is our answer for that bad boy. See, going a little bit faster on this one. Not all the videos have to be 80 minutes long. Alrighty. So, ladies and gentlemen, boys and girls, we have our tangents. Sorry for the pause there. I wanted to make sure I was still recording. Alrighty. So now we're on our tangent rule. So I'll zoom out so we can make sure we can see our tangents up there. So remember, once you know your x, it goes in the same spot, and your y goes in the same spot here. So again, we're going to steal that from our triangle over here. And so we're going to get the tan of x, which is 4/3, plus the tan of y, which is negative 12/5. And let's just do that part before I worry about down here. So I need to do a common denominator. So 5 and 5, 3 and 3. So this is going to go ahead and become 20 minus 36/15, which is going to go ahead and become negative 16/15. All right, let's now do the bottom where it's 1 minus tan x, tan y. So 1 minus 4/3, again, same as right there. And then times negative 12/5, same as right there. Again, once you get the hang of this, it's just more the algebra that can get saucy. So this is going to become 1 minus, let's do some canceling here. 3 goes into 12 4 times. So that's going to be a positive, because a negative and a negative are going to make it a positive. And then I'm going to get 16/5. Now we need to do our common denominator deal. So 5 and 5 there. So this will be 5/5 plus 16/5, which is going to go ahead and become 21/5. Alrighty, cruising along. This right here is our fraction, so negative 16/15. And then again, we're going to multiply and flip, so this is going to be 5/21. So do my canceling. 5 goes into 15 3 times. So this will be negative 16/3 times 21, which is 63. Booyah. Alrighty. So, ladies and gentlemen, boys and girls, on this one, I would love for you guys to hit the pause button and give this a try. See how well you do, because I think you guys can actually crush it. I'm going to erase this right here. One word of the wise is, remember that is a 3/1 for your tangent. Sometimes that gives us a little bit of sauce. So, let's go ahead and hit pause and then come back and let's see how you did. So, ladies and gentlemen, welcome back. Hopefully you didn't find the algebra too saucy, but let's go ahead and set this up. Just a lot of radicals. It's not too bad. So remember that that's over 1. So if we set this up, it's in x is in quadrant 3. Boom, boom. Quadrant 3. So this would be opposite over adjacent. Both of those are negative. And then when you do the Pythagorean theorem, that's just going to be a root 10. Not too shabby. Put an x right there, that is the x. Then in our y is in quadrant 2. Sign, quadrant 2 tells us right there. Boom. So it says 1/5. So this is a 1, this is a 5, and then when you do your Pythagorean theorem, you're going to find this is a 2√6, and then make sure it's negative because it's in the negative x direction. Cool? Alrighty, so let's go ahead and set up our first one. So for A, our rule of signs, so the first one is going to be negative 3/√10 for our first fraction. Second fraction is going to be negative 2√6/5. And then the next fraction is going to be -1 root 10. And then 1/5. hopefully that part you nailed down set. This part might have been a little bit saucy just because we're not quite sure how to move forward. So this is going to be 6 root 6 over 5 root 10. I can reduce this, but I'm actually going to not, because it's going to make my life easier just to do one rationalizing at the end. So I'm going to live with bad math grammar for just a second. So in the second fraction, it's going to be negative 1 over 5 root 10. So now they have a common denominator, which is super nice. So if they have a common denominator, we can combine them to become 6 root 6 minus 1 over 5 root 10. And this is where, again, you can't have a radical in your denominator. As we can see, we have a root 10 right there. So I'm going to rationalize this. So there's no radical in your denominator. And so all we're going to do is we're going to call this rationalizing. So I have to distribute this, though. Boom, boom. So it's going to be 6 root 60. Because that root 6 is in a radical and that root 10 is in the radical. So we're going to combine those together. But 60 is actually something we can break down to in a factor tree. So 5 and 12, 3 and 4, 2 and 2. There's your pair. So this is going to come into a 2 root 15. And then I have the 6 in front of that. So this is actually going to become 12 root 15. And now I can just do this 1 right here. So minus a 1 times root 10, or just root 10. And then this is going to become root 10 times root 10, which is just going to be 10. So 5 times 10 is going to give us 50. So that is our answer for that one. So that's why I waited to do the rationalizing at the end, just because that made our life a little bit easier. And so I recommend we do that until we get to the tangent rule, and then I'm going to say, I'm sorry, and we're just going to leave it as is, because the algebra is a little saucy. Alrighty, so let's go to part B, which was our cosine rule. So I'm going to do the cosine of both of them, so negative 1 over root 10, and then we're going to have negative 2 root 6 over 5, and now let's do the sines of both of those. So plus, it is a plus, right? No, it's a minus. Minus, there we go. Alrighty, then I'm going to do a 3 over root 10. 3 over root 10, I'm just making sure I did my sign, so that's a minus. It's going to turn to a plus here in just a second. Alrighty, and then last but not least here, it's going to be 1 over 5. Like I said, your signs are important, so I have my notes over here on the side, and I just wanted to double check I didn't do anything goofy. So in this first one, a negative and a negative are going to make this a positive 2 root 6 over 5 root 10 again, and I'm going to leave that at root 10. And then a negative and a negative are going to make this a positive 3 over 5 root 10. So thankfully they have a common denominator again. So we'll make this 2 root 6 plus 3 over 5 root 10. Now we need to rationalize. So we're going to multiply everything by root 10. So it's going to be 2 root 60 plus 3 root 10, 5 root 100. And then when we do all of our factor trees, we're going to go ahead and get you a 4 root 15 plus a 3 root 10 over 50. Boom shakalaka. Alrighty, so B's done. We're last to C, and then we're out of here. Erase this so I can just put it one line here. Alright, for C here, my friends, we actually have 2 options. So the first one is to go ahead and use your tan x plus tan y over 1, let's make it a 1 minus tan x tan y. And when you did that, on the top, you would get 3 plus 1 over a negative 2 root 6. And it's just 3 because, well, 1, they just give it to you. And then on the next one, for the bottom, you'd have 1 minus 3 times 1 over a negative 2 root 6. Okay, so if we continue down this train, on the top, we'd make this a 3 over 1. I'd need a common denominator, so this would actually be a 2 root 6 over 2 root 6. So this is going to give me, because 3 times 2 would give me 6 root 6 plus 1, minus 1. And that's because of this negative right here over 2 root 6. So that's my top. And then my bottom here, a negative and a negative is going to make this a positive. So this would be 1 plus 3 over 2 root 6. We'd have to do a common denominator, so we'd put this over 1. 2 root 6, 2 root 6. And so then we would get 2 root 6 plus 3 over 2 root 6. And what's kind of nice, if you guys tried it this way, when you did the flip, which we'll go ahead and show you, is 6 root 6 minus 1 over 2 root 6 times 2 root 6. Then I would have 2 root 6 plus 3. Those would just cancel. And so I would be left with the remainder here, which looks like this. And then we would do a complex conjugate to go ahead and say that this would be 2 root 6 minus 3, and then 2 root 6 minus 3, and then you would multiply from there. So that is a way you definitely could have done it. Now there's a shortcut, which is going to be this next part. You're like, why didn't you tell me the shortcut before? And that's a rule we haven't talked about before. And so we could say the tangent of x plus y is equal to the sine of x plus y over the cosine of x plus y, just like tangent of theta is equal to sine over cosine. Works the same way with where adding. Now it's got to be specific. Everything's got to be pluses, okay, to make this work. Well, we already know what the sine is because we did that first. This was our sine. This was our cosine. So technically what we could do is we could have just gone and taken our sine, which is 12 root 15 minus root 10, all that over 50. And then the cosine was going to be 4 root 15 plus 3 root 10 over 50. And then we would do the same canceling out. So this would be 12 root 15 minus root 50, all over 50. Sorry, root 10. I said 50. I apologize. Times 50 over 4 root 15 plus 3 root 10. And then the 50s would cancel, and you get 12 root 15. And then 4 root 15 plus 3 root 10. And then you'd have to rationalize from there. But again, we were going to say, let's take some bad grammar and just leave it as is. Okay. Now, I do want to mention, because somebody's are going to ask, you'll be like, wait, Mr. N, those numbers don't match. Yes, they do. They're equivalent. They reduce to the same number. They just look a little bit different. If you put both of them into the calculator, you're going to get about 1.734 ... They're the same number. They just look different because of our radicals. And so the next question was, would we accept both answers? And the answer is yes. So, ladies and gentlemen, that is our video for today. Hopefully you found it helpful. It was just using our rules and a lot of our SOHCAHTOA today. Okay, see you next time.